So I'll just start by saying that I'm going to talk today about some work that I did with my student Jenna Marks and developed into her dissertation, and I'm going to talk about developing an intervention to teach students rapid prototyping in order to promote productive learning dispositions around failure and iteration. Okay. So, obviously students often see failure as a bad thing, right? Often failure can be perceived as an indication of low ability or low intelligence. Yeah, if possible, I think that would be great. And of course, failure is associated with many, okay, I'll just wait.
Sorry about that.
Sorry, technical difficulties.
I thought it did yesterday, didn't it?
I think you just want to do view, I think, maybe.
It was definitely here.
It's okay.
Sorry about that.
That's okay. Okay. So, right, and of course failure can be associated with many negative outcomes, like negative emotion, lower intrinsic motivation, lower expectancies of future success, lower self-esteem, and so on.
Can you just put the mic a little closer to you?
Okay. Is that better?
Yes.
Okay, great. So, lots of bad things associated with failure, but I'm going to argue that failure can be a learning opportunity. I'm going to be careful in saying that I think failure can be a learning opportunity when the goal is to improve. So to learn something, to improve a work product, but not necessarily to perform. So we're not going to be advocating that students should fail a course, for example. And we're really focused on micro failures or mid-task failures that are relatively low stakes. So these are, failing to do a math problem on a whole worksheet of math problems or failing at the first draft of a paper. And I think failures can be a great learning opportunity when they provide informative feedback, right, or information, as Bob talked about. There is evidence empirically in the literature that failure can enhance learning over successes. And if you look at experts, for example, who are the pinnacle of success, we see that during training, they actually give themselves challenges just beyond their level of ability, which necessitates a certain level of failure, as Bob does for himself as well. And they persist after that failure in their domain of expertise, and they have specific mechanisms for doing that. So failure can be a great learning opportunity. So how can we teach students to learn from these kinds of productive failures? So I look to design thinking actually as an inspiration to design an intervention to teach kids about the value of failure. Design thinking originates in product design. It's basically a process and philosophy that can be used for any kind of creative problem solving. It's been used in many fields such as business, engineering, social entrepreneurship, and so on. And of course now it's bleeding into K-12 education. I'm going to focus on this part of the process. Let's see if my pointer works. Which is the sort of prototype and testing cycle called rapid prototyping. It's one portion of the design thinking process. Essentially what it is you create a design, build it out, test it in some way, reflect on it, and learn from that feedback you receive in the test, and then improve your design in some way. And so what this does is it sort of changes the way we think about solving complex problems, right? So often adults and children come to a complex task thinking that they're going to carefully develop a plan, make progress towards achieving it, and ultimately achieve their goal. But if we look at how people really solve messy, complex problems in the real world, it often looks more like this, right? Where you experience pitfalls along the way, maybe have to completely change your approach or perspective, right? And so rapid prototyping makes this process very explicit, and it incorporates the idea of learning from failure. So in the design world, you often hear this mantra, fail early, fail often, fail forward. And what it essentially means is that failures are a necessary part of design. You can expect to fail. It's normal. And therefore, we should embrace failure because it presents a great learning opportunity, right? They provide useful feedback for improving one's design. And we should risk early failure by jumping in with an early iteration to get some early feedback that can have wide implications for the later path of the design. Now, we can contrast this with failure in typical classroom cultures, right? There are actually few opportunities for students to learn from failure because there are simply few opportunities for iteration. In most classroom assignments, they're one and done. You turn in the math problem set, you get a grade, that's it. Move on. And there's some interesting research showing that American teachers in particular tend to avoid student mistakes, particularly in math classrooms. So a student makes a mistake and they tend to call on the student who knows the right answer so they can move on. And it's been speculated that this is because American teachers are very concerned with protecting students' self-esteem. And then, of course, as I've mentioned earlier, failure is often indicative of low ability, right? So all these kind of negative things surrounding failure in classroom culture. But the new instructional reform methods that are now bleeding into schools, such as problem-based learning, project-based learning, and inquiry learning, require iteration, which is going to lead to a certain amount of failure. So I argue that we need to give students some tools to cope with that failure. Now, if we look at how failure is perceived in design cultures, for example, there's evidence that rapid prototyping actually changes the way designers perceive mistakes. They take on this permission to fail mindset. It lowers the stakes of failure by reducing investment in any one idea and shifts the focus off perfection, and also minimizes the negative affect people feel around mistakes. So we set out to ask the question whether a brief intervention in rapid prototyping could foster positive learning dispositions and outcomes. And we really looked at 4 outcomes. Could students learn the process and philosophy of rapid prototyping from a very brief 5-day intervention, or 5 periods really? Would they develop more productive attitudes towards failure and iterative dispositions? And how would it affect their performance on a novel design task? So we took 5th and 6th graders in this study. We sort of randomly assigned them by class to 2 conditions: a rapid prototyping condition, which was explicitly taught the process and philosophy of rapid prototyping, which we distilled into 3 main points: the make, test, think process, make mistakes and learn from them, fail early, fail often. And then our sort of contrast condition to this was a content-focused condition, which I think mirrors the way design is typically taught in K-12 contexts. So usually students are taught the relevant science and math content for whatever design they're about to do, and they're told that good design incorporates those math and science principles. So we basically did just that. We taught them some science and math content and taught them to incorporate them into their designs. And here's kind of what the whole study procedure looked like. Essentially, we started by teaching them their respective processes. They did 2 design challenges, which we scaffolded. And then completed a design brochure explaining what a good designer is and sort of connecting it to their own lives. And then there were several assessments surrounding this. We had pre- and post-tests of design and STEM knowledge, surveys of failure attitudes, and measures of iterative dispositions. And then we gave them a novel design challenge that was completely unscaffolded. That's this boat task. And we looked at their iterative behaviors on that task and how they performed on the task as well. So here are the design challenges that occurred during the intervention. The first one is a drop challenge, where we told students to create a device that would stay in the air as long as possible when you drop it from a certain height. And so the relevant science content here is about air resistance and gravity, which only the content group was taught. And then in the playground challenge, students were supposed to design a playground that would have a maximum fun score, which is essentially determined by a formula of how many devices they have in here and which devices are more fun. And then during this intervention, we enforced either the rapid prototyping design process, so they did 3 make, test, think cycles for each of these challenges, whereas in the content group, they did what is very typical: a single make, a test, and a think. And then later they have this assessment, which is totally unscaffolded, and students do this part individually, where they have to build a boat that will hold the most number of nickels before sinking. So I'm actually, in the interest of time, I'm probably going to just speed through this slide, but essentially students did learn the design process and philosophy that was taught to them. The students who were in the rapid prototyping group developed more positive affect in response to failure, less negative affect in response to failure. And they also said that they would take more kind of productive actions in response to a failure scenario. So they would, be more likely to persist and try again and seek feedback and things like that. But we didn't get differences in their expectancies of future success. And this might be because we focus so much on failure and not how failure can translate into success. We also looked at, during that sort of unscaffolded boat challenge, what did students' iterative behaviors look like? So how early did they do their first test? So were they willing to jump in and try something quickly? And how many iterations did they take overall? And we did see some grade effects here. So the results here are split up by grade. You can see red is the rapid prototyping group, blue is the content group. You can see that for this time to first test, the sixth graders tested much earlier. And then in both grades, they took greater numbers of iterations in the rapid prototyping group. So they did seem to take on this kind of iterative disposition that we were pushing in our intervention in the rapid prototyping group. And then we looked at overall performance. So how many nickels did these boats hold at the very end? And in both grades, we see that the rapid prototyping group wildly outperforms the content-focused group. So these iterative behaviors seem to translate to much better performance on the task. And we did do a mediational analysis and found that the condition effects are partially mediated by time to first iteration. So that seems to be a particularly important part of the iterative process. So in conclusion, we found that this kind of brief intervention in rapid prototyping led students to learn the rapid prototyping process and philosophy, adapt more positive attitudes towards failure, engage in earlier and more frequent iteration, particularly the sixth graders, and also to produce more effective designs in a novel design challenge. So this suggests that the culture of design thinking, with its focus on rapid prototyping and permission to fail philosophy, can actually be successfully imported in middle school classrooms to promote productive learning dispositions, and might actually be an interesting way to encourage teachers to give students more iterative opportunities. More opportunities to learn from feedback and improve. And again, most of the work in design thinking research, especially in K-12, is highly qualitative. So this is one of the few kind of quantitative data points we have. And I should have mentioned this before, but there's a ton of work in design thinking in education that looks at how it can be used to teach content learning, right? Like STEM learning, or 21st century skills like collaboration and even engagement. But here we really wanted to highlight its value for enhancing learning dispositions, right? Like this approach to failure and an iterative disposition. So our goal with this intervention was not to enhance content learning, but it is something that we hope to do in the future. So it looks like I still have time for some lingering questions, so I'll just keep going. Maybe we don't have a timekeeper today. Is that the problem? What, I'm good? Okay. Well, I hope I haven't been doing it too quickly. Hopefully you understood the presentation. So anyway, some things that we're looking for in the future is, can we transfer these dispositions of iteration and so forth to non-design tasks? So if we gave students a writing task, for example, would they turn in more drafts? Or how do we make a bridge to those kinds of activities? Ultimately the goal is for students to learn these learning dispositions and the content simultaneously. So how could we integrate rapid prototyping with content-based instruction to enhance both of those things? Again, I think we could think more deeply about iterations and different types of iterations. For example, you can have an iteration just in your mind. You can do more informal iterations. So we saw, for example, students would we gave them an initial building task, for example, where they were building a tower. Students would do a kind of an informal iteration where they would just press down on the tower, but not necessarily formally test it with the experimenter. So there are informal iterations like that, more reflective iterations or high-quality iterations. There's lots of different kinds of iterations you can do and look at how that affects performance and learning. I think there's kind of this interesting trade-off between rapid iteration, which students love to do. They actually get really into this design process. They like to do things with their hands, right? But it often can conflict with that slower process of reflection that often leads to learning, right? So we really tried to build in reflective activities for them, but sometimes there's a trade-off between those two. So some thoughts for future work. Thank you.